Hello everybody, this is Cameron Snow, and we are continuing with our video series on geological risking for exploration. And this is actually going to be a two-part video. First of all, we're going to cover some basic volumetrics, and I'm going to show you a common mistake that I see, and then we're going to dive into the correct way to do it. All right, so let's get started here. Most of you should already be familiar with how we calculate volumetrics. But real quickly, we'll just review this. So we've got, we want to calculate, let's say, our oil or gas in place. Well, the way we do this is we have our gross rock volume, we multiply that by a porosity, multiply that by our hydrocarbon saturation, um, account for our formation volume factor, and that gives us our oil in place. Our gross rock volume, just a reminder, this can either be a gross rock volume calculated from a 3D model, or it can be an area times a thickness times a shape factor. And so that's how we get to our oil or gas in place. And then we want to get to a recoverable volume from that. And so we take um, our oil in place, multiply that by a recovery factor for oil, our gas in place, multiply that by a recovery factor for gas, and then we have our recoverable volumes. Now, a couple of caveats on this. I am showing these equations with just one value, and that's because for this recap, I just want to remind you of the basic formulations. Um, what I'm going to show as we move forward, is that there's a distribution of porosities and saturations and gross rock volumes that we want to take into account. Um, so that's a caveat there. I just want to point out now. But really, what we're interested in for this lesson is how do we factor in geological risking into this equation? Now, that may seem quite simple to you. I know what some of you were thinking. It's like, I know how to do that, you know? And what we're going to do is we're going to take these equations and we're just going to multiply them by our chance of success, by P sub G. Uh, and this is the wrong way to do it. This will give you an incorrect answer. What will end up happening is you will end up um, you know, overestimating on your downside and underestimating your upside results. I know this seems weird, but what you'll end up doing is you'll end up compressing your results essentially, where you won't think the downside is as bad as it is, and you won't think the upside is as good as it could be. And I see people do this all the time, and it is the wrong way to do it. So I hate to say that, but if you've done this in the past, you have made a fairly significant technical error that needs to be addressed. So if you've not drilled the well yet, it's not too late. Go back and update this using the correct methodology. So what is that correct methodology? Well, this is what gets into the second part of the video here, which is we are going to be taking a Monte Carlo approach towards calculating our volumetrics and our risk volumetrics. So let's dive into that. So remember, we've still got the same equation that we're using to calculate our oil in place and our recoverable oil and gas in place. It's just that we are going to be taking a different approach. So first of all, we want to be working with a range of outcomes for each of these properties. Like I've said many times before, there's not one porosity. There is a range of porosities. And so what we want to do is we want to use our Monte Carlo approach. And the first thing we're going to do is we're going to generate a distribution for each property. So we're going to generate a distribution of our gross rock volume, of our porosity, of our saturation, of our formation volume factor, and whatever else we're going to put in to this. Then what we'll do is the software is going to randomly select a point from each of the distributions. So it's going to grab our gross rock volume here, our porosity here, our saturation here, our formation volume factor here, and it is, and then we'll do that calculation, and we'll repeat this. We'll run this trial again and again, and so on. So and then once we've done this, we're going to calculate the outcome from each of these selected trials. And what we're going to do is we're going to repeat this thousands of times. So we are going to repeat this exercise of drawing a point from our distribution, um, you know, thousands and thousands of times, often 10 or 20,000 times. That's the great thing about using a computer, is it unlocks our ability to run this simulation very, very quickly, milliseconds. Um, and then once we've, done this, we'll then take the results of each random trial to build a distribution of the results. So we're going to then come out with a resultant distribution for our oil in place. And of course, you could drop recovery factor in here and calculate a recoverable oil in place from that as well. I just ran out of space on the screen, but you would drop recovery factor in here as well. And so that is how we are going to calculate our volumes. Okay, great, you say. Now we've got a distribution of oil in place, but you've still not integrated risk. Well, how are we going to do that? Okay, well, we are essentially going to do the same process, but what we are going to do is now we are going to have buckets for each of our risk categories. And so we're going to do the same Monte Carlo for our volumetrics, exactly the same as before. But now we're going to pull out a trial for our risk. And the way to think about this is our risking is a little bit different, because you don't pull a 0.8 out of the bucket or a 0.6 out of the bucket. What you pull out is a 1 or a 0. It is either a failure or a success. So if we think about that, for each of these buckets, let's say each of them has an 80% chance of success. Well, that means if we run 10,000 trials, we're going to pull 8,000 successes out of bucket 1, 8,000 successes out of bucket 2, and 8,000 successes out of bucket 3. And if all three are a success, then we have our oil in place. So we have a successful well, and if one of these is a failure, then our oil in place is 0 for that trial. And we're going to run this, thousands and thousands of times. And so what this actually leads to is something that is maybe not intuitive to a lot of people that are doing this, which is, in this case of 3 buckets, each with an 80% chance of success. That means out of the 10,000 trials, we'll pull out a 0 49% of the time. We'll pull out a failure. And in the case of a failure, what is our oil in place? Our oil in place is 0. So this means that for this well, 49% of the time, our 49% chances of failure, we end up with nothing. So everything less than your chance of success is a 0. And everything above your chance of success is some amount of oil in place. And so that is, how we go about generating our risk oil in place. Now, once again, I want to make the pitch for using a system for doing this. Once again, you can do this in Excel, but it starts to become complex, and you start to introduce the possibility for errors and inconsistencies when you're making copies of copies of copies and you're updating cells and variables. So once again, I personally advocate for using a system, and the system that I like to use is georiskx.com. So feel free to check out georiskx.com if you'd like to test out a system that'll handle all this complexity for you. All right, thanks, and I hope that was useful.